In this lesson, we'll finish the Change for a Dollar game by splitting it up into challenges. Let's review a solution for Challenge 1. The first thing I did was change my import statement, so I was importing the entire coins module. I'm anticipating having to write a lot of functions, and I didn't want to import each one by one. You can see how I'm using it now on lines 7 and 12. Then I added the logic to the test and refactored it to what you see now. The sum nickels function in the coins module is really similar to sum pennies, but we multiply the input by 5 to get the total number of cents. That's it. Alright, you ready for challenge 2? In this challenge, you need to complete the following tests. Test some dimes, test the sum of quarters, and test the sum of all coins. Start by creating the scenarios for each test using Gherkin, then write the tests and refactor. The test sum all coins scenario is new, but we want to make sure that once we have calculated the pennies, nickels, dimes, and quarters, that we can add them all up for a grand total. That's what this test is for, so make sure you cover it. One way you can write and save your features and scenarios is by using a feature file. I've created a coins.feature file to hold my feature and the scenarios against it. This makes it easy to keep my scenarios close to my code. PyCharm even has a plugin you can install, so you get formatting and IntelliSense. You should give it a try. That should be everything you need for Challenge 2. Good luck! Alright, you ready to look at a solution for Challenge 2? This will get easier and easier as you practice, I promise. Okay, we'll start with the scenarios and examples I defined for dimes and quarters. You may have different examples than me, but the gist for the scenario should be the same. Then in the test file, I've turned those scenarios into tests using the inputs and outputs from the examples. And then I refactored the logic into the coins module. Bada bing, bada boom. For the new function of summing up all the coins, let's go through that flow again. Take a look at my scenario, calculate the sum of all coins, but now I'm introducing the AND word. Given the input is 1 penny, and 1 nickel, and 1 dime, and 1 quarter, then the sum should be 41. In the test file, I turn that into a test using that example. Coins.sum all coins with pennies 1, nickels 1, dimes 1, and quarters 1, and assert the total is 41. And then I refactor that logic into the coins module, like so. Notice how my function takes pennies, nickels, dimes, and quarters, and I'm also using the built-in sum function to add or sum up all of the inputs that I pass in. I'm actually reusing all of the functions that I've defined above it, right? From some pennies, some nickels, some dimes, all the way to some quarters. Each one of these will give me a value, and then sum them all up and return that. What does your solution look like compared to mine? Did you do something similar? Maybe even use the built-in sum function? Or maybe did you hold variables for each one of these totals and then add them all together for a grand total? Is there an approach you like better? Why? These are all great questions to ask as you're designing code and looking at other solutions as well. You can take some things that you're seeing from me, take some things that you're seeing from others and your instructors, but ultimately, you'll start creating your own style of coding. And that's what makes programming not just fun, but really artistic. In Challenge 3, you just need to complete the remaining tests. Test with exactly $1, test when you're under $1, and test when you're more than $1. For now, pause the video and try to get the first test completed on your own. When you're ready, resume the video and we'll go over a new idea. Then you'll be able to finish the rest of the test to complete this challenge. Welcome back. Hopefully you were able to finish the challenge, but it may not have felt as straightforward as the previous challenges. If we were to take on a pure TDD approach and write only the logic required for test lose with less than $1, we'd have a test that looks like this before refactoring. We'd start with our total, coins.SumAllCoins, with one of every value maybe. The under would start at 0, because at this point we don't know if they're under. Then a message would be empty, because we also don't know if they won or not. Then we have the actual logic here. If the total is less than 100, then let's give under a value. 100 is minus the total, with a message value as well. You lose, you were under by under cents. From there we can then assert that under is 59 and the message has 59 cents in it. All in all, it doesn't look too bad, but once we refactor, things start to get a bit messy. We'd have a function that looks like this. This gets even more apparent when you see the over function next to it. The problem is that both functions care about the exact same input, the total. They also perform similar calculations and return similar messages. Because they share inputs and outputs, it feels like they should be together. And that's exactly the case. This is where going with the pure TDD approach can kick you in the butt. By mixing BDD with RTDD, we could have come up with a more generic scenario for the behavior we actually care about. Whether they win or lose, we generate a message and then print it out to them. This makes more sense once you see it in a scenario. Instead of the standard scenario with a single example input and output, we can use a scenario outline with multiple examples. This is much closer to the behavior we want, and behaviors are the functions in the coins module. But we will still write each of these examples as a test to make sure our code works. Just like a scenario, we start with the name, generate game result message. Then, given the grand total is total, when the result is calculated, then the message should be message. You can think of the examples as a table. There are 2 columns, one for total and one for message. Each row is a test case. For the first test case, the total is 59 and the message is you lose, you were under by 59 cents. The second test case, the total is 125 and the message is you lose, you were over by 25 cents. And then we have one more test case where the total is 100 and the message is you win. This time, we're going to start with the scenario, then write the function, and then satisfy the tests. With our scenario and examples written up, we'll start with this function in the coins module. I called it generate result, based off of my scenario, but call it what you think makes sense. From there, I know that this function cares about 2 things. 1, total as an input, as we can see on line 30 in our parameter list, and 2, a message as the output, aka what the function should return. Now we can use the generate result function in all 3 of these tests. Look just how clean and readable these tests are now. Total is the input, message is the output, and then we can assert our oracle on it to make sure we got the right message. Let's run the test real quick, and we'll see an error. It looks like our message doesn't exactly match because we have a lowercase y against an uppercase y. This is a simple fix, of course, just changing this and then rerunning it. But this is a weakness of this approach because our behaviors are now driving the specs, instead of the specs driving the behaviors. It's up to you as the software engineer to gauge each situation and use the approach that best fits your needs and your style. In the final challenge of this chapter, all you need to do is complete the game. Create the program to play the Change for a Dollar game. Start by creating a changeForDollar.py module where your program will be, and use the functions we already created in coins.py. They do almost everything you need to complete the program, and we know they work because we have tests around them, right? As a bonus, think of some negative scenarios, because there are sure to be bugs or vulnerabilities in our current implementation. To give you some ideas, what if the user enters an empty string, or a string of 10? How should we handle that? You get to decide and design it yourself. So have some fun with this challenge. Once you're done, submit it for a code review. The challenge is complete once the commit is approved and the branch is merged. Good luck!